So, good afternoon. This is Monica Bean. I'm a senior program manager with the Machine Learning University Educator Enablement Program. And I am joined today by our guest speaker, and we're so very excited that we have a volunteer from the field to be our webinar series, First Friday, number 2 uh, kickoff webinar series. And this is our second one. And so we started with Amazon, our own. Mia Meyer presenting last time on the responsible AI. And now we're going to be shifting gears a little bit and having a practitioner who not only works as a professor at the Channel Islands Community College or Channel Islands College System, but also works in the field of AI ML. And so he's going to talk today about bridging from education to career and how that whole process works. So I'm going to stop talking as I know others are joining, and you really want to hear the speaker today. So I would love to introduce you to my newfound colleague and friend, Dr. Michael Soltis. Take it away.
Uh, Thank you so much, Monica, and thank you very much for the invitation. As Monica said, I am Michael Soltis. I am a professor and chair of computer science at California State University, the Channel Islands campus. And I'm also a principal scientist at GBL Systems, a company that is a defense contractor here in Ventura County. And my talk today is going to be machine learning, and especially on the link, the bridge from academia to the industry. And I'm very grateful for the invitation from the Machine Learning University. And I have to say that I find the collaboration with MLU very fruitful. I saw two excellent talks when we met in Seattle in January. One was by Brent on the future, past and present of machine learning, and the other one by uh, Maya on the ethics of AI. And I have to say that I have shamelessly used some of those ideas in a talk I gave yesterday to a regional defense partnership, where I was able to talk about the evolution of machine learning and some of the challenges related to the ethics of AI, especially in the defense industry, thanks to the important and interesting things I heard during those two talks at MLU. You know, the cost of doing machine learning is time you need to invest in learning, and MLU can be a fantastic resource for academics and practitioners as we go to quickly acquire knowledge, go to the well, as it were. So let me say a little bit about where my machine learning experience comes from. I did my PhD in computer science and mathematics at the University of Toronto in the 1990s. And during that time, there was a faculty there whose name was Jeffrey Hinton, and he just came from the UK to the University of Toronto. And the reason he transferred from the UK to Toronto was that his funding for doing research in AI dried up. And the reason for that was that he wasn't getting any results. He had this crazy idea about using deep neural networks, an idea that was already around in the 1960s with perceptrons, to solve the problem of computer vision. And he had a couple of students, and he had no funding, and he was teaching an interesting course in statistics, and I took that course, and he talked a lot about uh, how to use machine learning to solve the problem of vision. And it took him only 20 years to realize that vision. By 2012, he won a competition in vision, telling cats from dogs, and at the same time, Google bought his startup that was using some of his ideas, some of the ideas he developed in his research, and that became the company DNN Research, which then was the foundation, the seed for machine learning at Google. So that's interesting. I've seen this kind of meme go around lately that in 1903 the New York Times wrote this piece that flying is simply too difficult for man, that this is never going to happen. And a few weeks later, the Wright brothers were flying. So Jeffrey Hinton believed that it could be done, and human ingenuity is magnificent. And I think that's a nice lesson that things that seem impossibly difficult today may have simple, nice solutions just around the corner. My advisor at the University of Toronto was another computer scientist. It was Stephen Cook, who came up with the idea of NP completeness. And I worked with him on a problem in artificial intelligence. I was working on automated theorem provers. So we all know that machine learning is computation based on data. That is, you replace computation with data, as it were. The emphasis is on the data. But in the 1990s, the main thrust of work in artificial intelligence was on logic rule-based systems. And Stephen Cook, with his idea of NP completeness, led that effort. And well, it's 20 years later, 30 years later, we still don't have automated theorem provers. So some things come to pass sooner, and some things it takes a little while for them to be realized. And based on the on everything I learned from a fantastic team of faculty, I wrote a textbook in algorithms, and my emphasis for many years was in the correctness of algorithms, but the seeds that were planted in my head by the pioneers of machine learning at the University of Toronto in the 1990s, I guess, germinated for a while, and now I am all in that field. I want to mention two more interesting people that the idea of standing on the shoulders of giants. There were uh, great people I was lucky to learn from. Another scientist that I work with very closely was Dave Parnas, who many regard to be the founder of the field of software engineering. He came up with the basic ideas of object-oriented programming and with concepts such as polymorphisms. But the key thing that he emphasized, which didn't seem, I have to be honest with you, didn't seem exciting to me at the time when I was hired. It was my first faculty position at the University of McMaster. The thing that he emphasized was documentation. So software is as good as its documentation. And to me, documentation at the time seemed like such an afterthought. Like the exciting part is to develop the software, but who cares about writing manuals? Well, the documentation is absolutely crucial to the success of a piece of software. First of all, your team changes, new people come on. How do they know what is it that you've done? How do you maintain code? And how do you convince yourself and other engineers that the code that you have written is correct? And I think that one of the reasons I found AWS to be such an attractive collaborator is because of the fantastic documentation. The services have well written, well structured documentation, so that even if you're working on these things by yourself, say SageMaker or S3 or EC2, whatever, you have access to current documentation that explains things in detail and well structured. And now, many years after this, I see the benefit of documenting software well, especially in my field of software development, where we build, the company I work for, we build models, machine learning models, all the time for different applications. And documenting that work, part of it is done automatically with tools like Git, but a lot of it has to be done by hand, and having that discipline of maintaining good documentation, that is a strong component of a successful piece of software. And really, my first the first time I was introduced to the basic ideas of machine learning was by Professor Jan Michalski, who was at the University of Colorado, and who gave me this book from the 1960s by Marvin Minsky and Papert on perceptrons. And it looked kind of quaint to me at the time. It looked like, kind of old-fashioned science with the book is nicely published with hand drawings. And then when the second edition came out, there wasn't money to type it. And the corrections in the second edition, which was the one I had, were written in by hand. It's kind of really nice, quaint book. But if you read it and you study machine learning today, you realize that a lot of the ideas of machine learning are are old and they're just repeated. And the reason we are doing it today is not so much because of conceptual breakthroughs, though those are there as well, but the mathematics and the neural nets and all of that was already known in the 60s. The reason we're doing it today is because the cloud gives you access en masse to people to do these types of computations that 5-10 years ago were beyond the scope of the possibilities of most individuals and even most institutions. So it's interesting how, yes, the hardware, NVIDIA chips in gaming and then in machine learning, but really what makes machine learning a practicable tool, what democratizes it, is the fact that you can access tools for machine learning in the cloud and pay as you go, rather than have to buy expensive software as the first, expensive hardware as the first step of doing machine learning. So currently I am at the California State University, Channel Islands. Before I was at UC San Diego, and we're a small campus in Ventura County. We have 7,000 students, and 60% are Hispanic, and 65% are first-generation students. And we have a beautiful location. We're in the Santa Monica Mountains. The Santa Monicas are a strange mountain chain because almost everything goes north and south in terms of mountain chains, and they go east-west. The east end is Hollywood Hills, and we're in the west end, just where then if you would continue, you would hit the Channel Islands. But we're not on the islands. Parents always ask us what time the ferry leaves for the campus, but we're on the mainland. We're about 45 minutes north of Los Angeles. But it's an agricultural working class community. It's very, very beautiful. There's a lot of fields, and the campus is very nice. The tower of the campus you see here by the fountain is it is the building in the Song of the Eagles Hotel California. Was written with thinking of this tower, I think, and the reason is that the university campus was in the 1920s and 30s a posh Hollywood rehab center. It only became a campus about 20 years ago. So it has this nice old Spanish colonial architecture. And in our neighborhood, there's two large Navy bases, Point Mugu and Port Hueneme. And there are many defense contractors. And I am a principal scientist at GBL Systems Corporation, where I do a lot of machine learning applications for the Department of Defense. And I'll mention a little bit the work I do. Most of it is classified as you would expect, but a few things I can mention. So who are our students? And I suspect our students are similar in many ways to your students, wherever you are in the nation. As I was preparing this talk, I was trying to characterize our students. I like them a lot. There's a lot of talent, Intellectual ability is not something you inherit. It's spread out almost randomly, and and there is a lot of it everywhere, and there is a lot of it in our community, of people who are very often first generation to go to college, and they have this, many of them have this nice hunger for knowledge and for improving their lives. So first of all, we have less and less of your classical freshman student, supported by their family, who come to college and do 4 years and then graduate, start work, start a family. A lot of our students already have families, or have family obligations, or have elderly parents, or have children. So you have to take that into account. So many of them work. So you have to accommodate that. You teach in the evenings, or you record your classes. The families are, by and large, people who worked in the agricultural fields of Ventura County and other working class families, and they have a very practical approach to sending their kids for 4 years to a university. What's the ROI, right? I mean, I need my son or my daughter to help me run the family store, or to work in the fields. And instead, I'm going to send them for 4 years to your campus, pay tuition, not have the benefit of their help with the family business. Is what they're doing there worth it for them and for us? That's a question that you have to know how to answer straightforwardly. First generation to go to college, their participation concept has changed. It's very different from when I went to university. They live a lot on social media, and they use things like Discord. I have a picture of a typical Discord invitation on our campus, and that's how students communicate regarding their classes, assignments, team up. They learn through activity. So what do I mean by that? What I mean is that some years ago, I was able to give my students a paper to read, or say, read this chapter in a book, or learn this math. If I do that today, I would say for 95% of them, nothing comes of that. They're not trained from high school or other experiences to do intellectual drudgery, as it were. So you have to engage them in a way where they learn participating or being active in something. So I give them increasingly more difficult problems, where for them, or activities rather, where they build something. In AWS, very often we are an AWS Academy institution, so we use a lot of the AWS resources. So they build something, but to build it, they have to acquire knowledge that is part of the curriculum. So that approach works a lot better than just giving them knowledge. It's one of the reasons when we teach machine learning, we don't emphasize, especially at the beginning, the algorithms and the mathematics of machine learning. We kind of emphasize building a solution to a problem that requires machine learning. And Monica, can I just verify that the audio is okay, that you guys can hear me and there isn't too much background noise?
Yeah, everything is great. Yeah, you're doing fantastic, Michael. And while we're pausing, you did have a question, and I was going to pose that at the time. So, someone asked if have you ever taken a course from Dr. Hinton at U of T?
Yes, I have.
Well, there's your answer, David.
Yes. The language, he was considered, the one of the founders of the field of programming semantics, and yes, great guy. So cannot assume background, learn through activity, and they are ruthless judges of the usefulness of material. If they feel it's not leading them to a career that they have in their mind, or to a job, or has a practical application, that idea. So part of education is they don't know everything coming in. Otherwise, they wouldn't come in. So part of education is to form their imagination as to what is useful and what isn't. But you have to do it gradually. And thinking about our students, another word that came to mind for me now, I'm talking the last year or two, is that they seem lonely to me. And it could be a combination of factors. But I see a lot of literature coming out, and I started reading about it a little bit. COVID restrictions and isolation, for sure, was one of the causes. But I think also social media is this double-edged sword. It kind of, it seems to bring you closer to people, but in fact, at the same time, it isolates you a little bit. And I find them, it surprises me, for example, that our students don't really date very much. When I was going to college, that seemed to be the best part of going to university. But so you have to take that into account, and I think that you can help with that. And one way we help with that is we team them up, sometimes randomly, sometimes we let them form their teams, and I can sense a profound sense of gratitude from them, because these teams become, colleagues, and then maybe develop friendships. So that's something that I take into account. How do we teach machine learning to our students? So we need to motivate them, right? So as I've said, they have a very practical outlook on things. So how do we motivate them? Well, there is a lot of talk of machine learning in the media, so it's topical, and that does some of the work of motivating the field for us, because they read and hear about it. Chat GPT, everybody has an account, everybody's trying it out, they're using it to write assignments, right? The second thing is what I told you about our audience. Who are our students? They're working class, first generation to go to university, and their expectation is that it's a stepping stone toward a satisfying career that can, in many instances, lift their family out of poverty. So career opportunities have to be emphasized. And again, this is something that machine learning, it's easy to do it for machine learning. 40% market growth, 40% jobs automated by 2030, but someone has to implement this automation, and somebody has to maintain this automation, and it can be them. And LinkedIn lists so many jobs in machine learning as well. The other thing is visualization, and there's so many examples. AWS MLU has these nice examples of linear regression and clustering in GitHub, where you can kind of see the animation as you scroll down. You see things working together. It really appeals to their imagination. It forms it. It gives them a visual. As you know, the bandwidth for absorbing information, the visual bandwidth for absorbing information is several orders of magnitude bigger than absorbing information through, for example, listening, right? So good visuals are really important, and you can find a lot of those in machine learning. For example, here is this. Matt Henderson has these nice animations that show kind of in time how these machine learning algorithms develop, and that is very appealing, because if you start from the mathematics end of things, you will lose them. But if you start with the visualization, they want to, well, how does it really work? So that can be an invitation into looking at an algorithm. But again, we're not emphasizing algorithms so much. And then start the process early. There's so many threads that come together when you teach machine learning. You have to have Python, and that we already teach to the freshmen. Great language, low entry barrier, and scripting, so you can quickly and succinctly express fairly complicated things with great libraries. We all love Python. Jupyter notebooks. So we We teach them a lot with Jupyter notebooks. If you think about it, Jupyter notebooks go back to the idea of Knuth of literal programming from the 80s and 90s. But that way of combining both code and instructions and documentation is fantastic. But you have to emphasize that you use Jupyter notebooks more for prototyping, which is, big chunk of the effort of any endeavor. But that you need something a little bit better if you're actually implementing a system, a machine learning recommender system, and where you're constantly retraining the model, refining it, rebuilding it, attaching it to endpoints, and so on. And then you do need to do a little bit of math. We actually do quite a bit of it in the end, but it's kind of at the end, not at the beginning. Machine learning was a field of statisticians and mathematicians, and they brought their perspective on it, and it was often taught as a mathematics endeavor. And again, we teach it as an engineering endeavor where you're trying to solve a business problem somebody has. And sometimes this business problem can be solved with machine learning, and very often without. And if the simpler solution doesn't require machine learning, you shouldn't be using machine learning. And that's a lesson I learned in the industry. And that Gartner hype cycle, I think Brent showed it to us when we were in Seattle in mid-January. There is this curve of hype. Initially, you throw machine learning at every problem, but not every problem requires or should be solved with machine learning. And that's kind of a wisdom you have to transmit to them as well. I'll mention two machine learning projects that I've worked on recently. So the one on the right, I can talk about it more because it's open source and we've written a paper based on it. The one on the left is from the industry, where we developed a tool called Sage Tech that is used in the DoD. So I'll say a few words about Sage Tech because it's a really interesting application of machine learning. And then I'll say a few words about the other project. So how did Sage Tech come about? Well, it came about in the following fashion. Again, avoiding details, imagine that you're given a black box that has a certain function. On given inputs, it produces outputs. And so much software out there is legacy. In the health industry and the finance industry and everywhere, there's a lot of legacy software. So somebody wrote the software for the black box 30 years ago. The documentation was never there, probably, or it has been lost. The people who wrote it, even if they're around, they don't remember. So what can you do? And we found these black boxes that were Fortran wrapped in COBOL, wrapped in another layer of Fortran, and then probably there was like a machine language module there as well. But it was an important black box that had an important function. So reverse engineering that thing to rewrite it in, say, C++, so it can be used in another system as a component that is well understood. After a while, it's out of the question because we can't figure out how it works. There's so many magic numbers in there, and somebody poured their understanding and wisdom of a field into code without explaining how. Documentation. So how did we apply machine learning in that case? Well, we basically, for given inputs, it produces certain outputs. So those are your labels, and you produce enough of those input-output pairs, and you train a model on it. And our model actually works better than the black box because it generalizes, whereas the black box had a lot of exceptions that our model doesn't. I found it to be a really nice and elegant way of applying machine learning. Notice that here's an important point. We still don't understand how the black box works, but we know because, I mean, yes, it got trained on data. Fine. We have the original black box. We have a new black box, which is conceptually simpler because it's just a model, but we still don't understand how it works. So understanding how a model expresses epistemology, I think, is the next phase of machine learning.
So, Michael, we have
Next,
a question.
go
Sorry to
ahead.
interrupt you. So it's from David. He wants to know, do you teach Java besides Python?
We teach Java. We actually, our intro to computer science, the Comp 150, 151 in the first year is in Java. There is a kind of a pre-Comp 150, 151, 105 that uses Python, and then they use Python many times in the course of their education, but we focus a lot on Java.
Thank you.
So let's look at the machine learning on the right. It's in I have it in GitHub, and I was going to show you just a couple of examples. It's just let me see if there's anywhere with. Okay, I'll just say briefly what it is, because it's the idea that is interesting, not the details. So the idea here is that we get a lot of applicants who to our campus, but at the end of the day, in the fall, 10% of them end up enrolling. Okay, there's a variety of reasons for it. We want to enroll more. We're 5,000, 7,000 students, but we have capacity for 15. So I collected data from the university for the last 6 or 8 years of enrolled students who then I pared down to enrolled and admitted. And then I saw among the admitted ones who were the ones who end up coming to campus. And very interesting. So every student that applies now is run through my machine learning model, and it attaches a probability of that student enrolling in the fall in our campus. And that's very good. But there is a second thing that is more interesting here. The second thing is we have a machine learning output, but how does that translate into policy? That's an area that I've been getting really interested in. Okay, you have a machine learning result, but you're going to be making decisions. What's the link between the decision, the policy, and the machine learning result? So in our case, those who are very highly probable to come, we don't have to spend money on recruiting them. Those whose probability is very low, we also don't have to spend money on recruiting them. It's the ones in the middle on the fence. That's very good. That really saves a lot of resources for our admissions department. And I have written a paper about that project, and it's I think if anybody's interested, I'm happy to share it.
Michael,
I'm
if you
almost
could
done.
share that, that would be fantastic. There is definitely some interest, so we can send that out to everybody later.
Excellent. So I have I think 3 more slides, and this one has some content with it in it, but the others are just 2 pictures. So please don't despair. So I think that it's important in machine learning to teach what academics would consider. So what is important, but academics would consider it not elegant. It actually is very elegant, but you have to get to know it. So spend more time not on the mathematics, the algorithms. So spend time in the industry. Where is the effort in machine learning development? Well, it's the CI/CD pipeline. You're building a model. It never works. You have to refine it. You get new data. You get partial data. You get new data that contradicts the original partial data. You have to rerun, retrain. Then you realize that the hyperparameters were chosen the wrong way by the previous team. The results you're getting are completely wrong. What you need is this nice cycle of development and refining a model, and then also quickly deploying the model if it's deployable. How do you attach it to an endpoint? Right? Things that you can kind of do very quickly from Bodo 3 and SageMaker. And you can also close the endpoints when you don't use them because they are expensive to maintain. Documentation, really spend time on that. It is the assurance that your solution will have some legs and it will be used beyond your interest in it. Remember that machine learning just usually doesn't work, and it takes persistence to get the model right, and then the window when it is right, if it's applied to something that has a tendency to change, is relatively small. So have these realistic expectations about it and communicate it to the students. It's not magic that solves everything. That ChatGPT is an amazing technology, but has that detrimental effect of making it look as if machine learning were magic. Can solve everything. Communications, interpretation of data, like I talk about policy related to results, and the ability to communicate those results is really important. In fact, all of our students get jobs, but all the employers we have, and most of them end up working in the region. Some of them go on to Google or AWS, move to Seattle or somewhere else, Denver, but most of them end up staying here. We have great relationships with the employers through an advisory board. They all tell us, your students are technically excellent. Their communication abilities are abysmal. And they're required to be presenting all the time. So over the last few years, we've really spent time on teaching communication skills. How do you craft a good email? Not too long, not too short. How do you do a presentation to your team? And they have to understand politics of data. I would say in our projects at my DoD company, not my company where I work at, hours and days go to negotiations of the usage of data. And is the data, are they going to sanitize it? They're going to, but then if they sanitize it too much, they take what's really the interesting kernels in it out, and we cannot give them the results that they're seeking in the first place. And then it takes so many signatures and so many, so there is that political aspect of getting data that is also a very important component of doing machine learning and data analytics in general. Finally, excellent book. I highly recommend it. In the US, we're growing very quickly in AI, but other countries are growing even quicker. I was at the Navy Machine Learning Conference in San Diego last October, and the keynote speaker spoke about this book. I read it just recently. It's really good. How the emphasis in China is on implementation and integration of systems with machine learning. Very little emphasis on the like, I'm talking really broad terms in the scientific aspect of it, let's say. And there's this beautiful example there of students at a regional university in China. They're working on their homework, and light go out, power goes out. So students take their books and their notebooks and they walk out to the street and they sit on the sidewalk under the street lamps and they continue working. And it really impressed me because the author was using that example to show that the perseverance, the tenacity, and the enthusiasm for learning that many people there have. And finally, I want to say that in some sense, the university, that bridge, tying back to my title, the bridge between academia and business or industry, we're connecting two very different worlds. in academia, we have stovepipes. We have computer science, we have business, we have mathematics, communication, law, ethics. All of those are neatly compartmentalized in different departments done by different faculty. But when students cross that bridge to the other side, they realize that they really need a cross section of all of these things. So integration of that a little bit on our side is also very important. And I believe that's the last slide. Thank you.
Thank you so much, Michael. You have a few questions in the chat, so I'm going to read those first. And then others, if you would like to ask questions of Michael directly, feel free to use the raise hand feature, which is in the bottom left-hand corner, it should be, of your screen. And then we will take those in the order of the queue. Or you can post it in the chat window and we can ask other question for you. So Michael, we have two questions right now. Brian says that he can't see the repo on your public GH. Is it private?
The GitHub repo with the enrollment problem, yes? Yes, that one is private, but I can make the paper that describes a lot of it public.
Yeah, he said
I'll send,
enrollment. Yes.
yeah.
He said, thank you. We have a question from Ariel. Michael, does your department offer a degree in data science, or is it a BS in computer science with concentration in machine learning? And do you have a minor in machine learning?
We don't have a minor in machine learning. We probably should. Though in general, my approach has been to avoid university administration as much as possible because the development cycle is so long that we end up just teaching it by adding the content to different classes. So effectively we do, but in the books we don't. And the other question was, sorry, I didn't remember the first part of the question.
The first part, so does it have a degree, data science, or is it a BS in computer science with a concentration in machine learning? Do you have a minor in machine learning?
For historical reasons, our data sciences is in mathematics, and it is very theoretical. So it's really statistics.
Okay. We have another question from Rabina, and you're on there. If you want to just unmute, you can ask yourself.
Um, okay, can you hear me?
Yes.
Yes. Hi.
Okay. Hi, Michael. Hi, Bean. So my question is, I'm a last year student, and I wonder if there is a big gap in the practices that we have in the books, in the tutorials that we find online, and what really happens in the companies in industry, and what are the things that you have seen that highlight as the most different, and how do we catch up for those if we are in the classrooms? Thank you.
It's a very good question. I think the assumption there very often is that, graduating students who start a career will learn those things they need at the company by kind of osmosis, that they have the technical savoir-faire from the university, and now they will learn the business aspect of it. And so that can be quite a cultural shock, because you realize that the paradigms at a company are so different from the paradigms on campus. For example, there is a very, very strict budget to do whatever, and you have to develop your tool within that budget. And also, most of the time, you don't start working on a new tool. You're put on a team that's halfway through developing that tool, and before that tool is finished, you move on to another team. So there are all these things that you're not prepared for by the university. So the way we try to compensate for that, and there may be other ways of doing it as well, is we have a really thriving internship program. So our students starting in their second or third year are placed with local companies, so they start learning that other side of things early on.
Michael, we had a question. Are the slides going to be available after this presentation today? Are you able to share those with participants?
I put them on my webpage and my talks. If you just Google Michael Soltis talk, and my talks are there. But I can also send them to you, Monica, if you prefer.
We'll put the link there to your Google page. That way it's preserved in this presentation, but then I can also send it to the participants list as well. So, any other questions for Michael? We have about 13 minutes remaining of our session today. Feel free to unmute yourself. Michael, you've raised your hand. Michael Tanner?
Yes, I
Go
did.
ahead.
I really just want to say that this discussion, Michael, that you've gone through with us has been very enjoyable for me. I'm actually in the throes of getting my children. They're starting college. They're 17. They're twins. They're starting college in the fall, and we're picking out colleges. My son, in particular, I've sort of steered him, given I've come from the computer industry, into cybersecurity, and I've actually had him listening in. He had to go to work, but I've actually had him listening in, and it was a really nice discussion to have him hear a lot of the theory, talking about how the schools, what they teach, and talking about the machine learnings and the artificial intelligence. I've talked to him about that. I'm not qualified to really talk about it that much. I've talked more about the cybersecurity aspect. But I just want to say a long-winded way of saying that I really appreciate this discussion. And from my standpoint, it was very enlightening for me to hear you talk about the history. I go back a little ways in the computer industry, and I remember I'm going to give away a little age, but I remember back in 1983 when I was in college, and my database, my relational database teacher, which was, that was new at the time in 82 or in the newer generation, and he was talking about one day before 2000, there'll be interpreters that will be able to have end users use plain English words to request computer code. So we won't need all of the army of programmers. And, I was in the industry and I followed it, and 2000 came and gone, and it never came about. And I said, oh, he was wrong. He made a long range prediction and he was wrong. But now we see that he wasn't really wrong. He just, like a lot of us, had his timing off. So again, I just found it very interesting, the discussion, and whoever has put this together, thank you so much. I'm not sure how I got the link to attend it. I am taking some AWS courses at a college here in Long Island, New York area. So I'm so happy that I got to listen to this. So I'm done. Sorry for my long-winded statements. Thank you.
No, that was great, Michael. Thank you. That was very, very interesting comment. And yes, he was just off by 20 years. Now we have Code Whisperer, right? That is able to write code automatically, kind of like a chat GPT, but for code.
Michael, Kayla asked, do you have any advice for those who are just starting in machine learning or who are more on the beginner level?
I think the approach AWS MLU espouses is the right one, of Jupyter Notebook and just doing it at first to get a feel for it, to get the excitement of running a machine learning on, a toy example, especially through SageMaker Studio labs, where you can have access to repositories with data and you can play with it. I think that is so satisfying to see it work right from the get-go, and jump into the details and the math and the stats and everything else later on. That would be my advice.
Great. And also, Ariel, you want to come off mute and ask your question? You have your hand raised. We can't hear you, Ariel.
I think you're still on mute, Ariel.
Still on mute.
Okay. Thank you, Monica, for organizing this, and Michael. This is so great to hear everything that you share with us. I'm a mathematician. My formal training is in computational applied mathematics. So I come to actually from the angle of modeling, using mathematical models for infectious diseases. That's what I learned when I was a grad student and a postdoc. And so modeling and using data and making sense of data to understand processes, it's something that has been very at the core of my career. So when I saw in some parts of your talk, Michael, that you said something about the mathematical foundations or something like that, that were not at the starting point, it really, I think it's very important because in my understanding, um, calculus readiness or even algebra readiness, it's is a big barrier in higher education in the United States. So there's a lot of college students that are not calculus ready, and really it's like their algebra is very weak or non-existent, and that causes that basically steers them or excludes them from any STEM major, especially initially. And I think if I understand your approach or in your program, eventually they do get into the algebra and calculus, but that's not where they start. So I think that's very um, we should all emulate that. Like don't just send those people away just because they have difficulties with they're not calculus ready, but get them with Python, get them with some Jupyter notebooks, get them with opening some data frames and looking at some visualizations and get them excited. And I think that's a much more it's I think it's more practical. I mean, from practical machine learning, definitely that's very practical. And I work with some mathematicians that are very traditional. I think maybe some administrators, I don't know if they're that traditional, but there are some people in academia that it's like if the student doesn't know calculus, then they have no business in college or something like that. And I think these times merit we're gonna have to reinvent higher ed, and I think this is I don't know, very pertinent.
Very good point, Ariel. I agree with you.
There's definitely some agreement in the chat as well. So lots of thumbs up. There was an amen. So I think that was a very, very valid point, Ariel. Thank you for sharing. Any more questions for Michael? We have about 6 minutes remaining of our time together today. David says the coding school teaches AI to high school students as well. So Dan O'Brien is raising a hand. Dan, go ahead and come off mute.
Hi, thank you very much. A great presentation there, Dr. Soltis. Do you have any feeder programs from community colleges or technical schools? I'm at a community college here in Virginia, and it looks like we're going to get a grant to create a new community college to four-year college to industry pipeline. And funny, it came up. How about machine learning? How about data science? Do you have any suggestions about what a program like that might entail to feed to a college like yours, that offers the computer science degree? What are maybe some good classes to prepare students?
It's a very good question. I'll be honest with you. The emphasis for me has been the other end a little bit, in the sense that I have been thinking and helping students transition from their senior year into their first job or into their career. But we as a university, we spend a lot of time working with the local community colleges and high schools. And I think, and this goes back a little bit to Ariel's point, that it's important not to make it too strict and too sequential, what you learn, because if you have to learn calculus and then algebra and then that and then Java object oriented, you can the initial enthusiasm and excitement about an idea that you've seen can be lost on the way. So I because machine learning is really a broad subject, I think it's good for those who will be doing machine learning to see as many things as possible, because everybody has talent. So some of those things, they will make quicker progress, and that will help them to get through the more difficult things. And the more difficult things, more often than not, are precisely calculus, as Ariel said before. So I think introducing machine learning ideas in practice early on, that's what I'm trying to say.
So
Yeah,
Michael, can
thanks.
I
That's
just add
great.
in? Sorry, can I just chime in? This is Myra. Sorry about that.
Mhm.
So Dan, you're in Virginia, correct?
Yes.
Yeah, so we are going to be working with VCCS, and we've done this exercise before where you can work with some of the local colleges to work on a 2x2. And a lot of it is just through articulation agreement, right? So like, it's not so much to align on the content, but it's more what we found in the past. It's more about like having them see your courses as a starting point, and then the courses they take at at the four-year university being an extension of that course. And we've been pretty successful in the past with helping to create 2x2s in Virginia, and that's some of the work that Monica and I are doing also with the colleges and community colleges to hopefully work through that. So we're happy to meet with you separately.
Oh, that's great. Thanks. Yeah, I agree, Dr. Soltis, that uphill battle with calculus is a tough one. And
Mm.
then, hey, how about some discrete mathematics and linear algebra on the side? And the students are going, I just want to make pretty pictures, and learn how to train a model. What are you talking about calculus for? And
Mm.
so what we've been good at is getting people into the entry level jobs with a couple of classes, and then say, hey, now you might want to look at the 4-year degree, and you're going
Mm.
to have to take, calculus and linear algebra. So thank you.
Mm.
That's all very, very good. I really appreciate it.
Thank you.
We are closing in on time, so if there are no other just burning pending questions, I don't see anybody with the raised hand. No one's in the queue. Okay, with that, I just would really like to say thank you, Dr. Soltis. This was an amazing hour to spend with you and your colleagues today. We are not the voice that is the end all be all. We learn from each other, and so we are very appreciative of the fact that you came to the webinar series today and not only shared your experience as a faculty member, but also your experience working with classified data sets that you can't share with us, but we are very curious about what those might be. And so, bridging the connection between education to application of that knowledge is why we're all here. And so we really, again, just appreciate you taking the time. If you will send me that presentation, I will send that out to the group. And then before you leave, Michael, can you drop in the chat the website, your website for us? That way I have it captured as well. And if those who are watching might just want to go ahead and click directly on that, so you'll have that link in that presentation and probably some other amazing resources as well. And I just want to thank the audience. Thank you so much for asking the questions, for posting comments in the chat. A lot of head nodding going on, a lot of plus ones. So we are all in this together, and it makes it a better pathway for all of us when we're doing it together. So with that being said, I'm going to stop the recording. And after we see that, perfect. And then I hope that you all tune in next month. Someone did post that they got a notification that it had been canceled. I think someone who received the invitation like accidentally deleted it, but it will always be there. It's the same link. So you have this saved, put this in your calendar every month. And next month, we'll be hearing from somebody at Amazon, AWS. And then hopefully in May, I had to do some math there. Hopefully in May, we'll have another volunteer. I know we already have a volunteer for June from Laney College and from the system there to talk about what they're doing. So that will be really timely. And if you want to volunteer for a future session, reach out to me. Please let me know. And until next month, I hope you have a great afternoon and a great weekend. Thanks, everyone.